Hi guys, Professor Burns here. We're going to look at section 2.3 and now we're moving into categorical data. So previously in the chapter we spoke about numerical data, which remember involves measurements, counts, numbers of any kind. Now we're looking at categorical data, which remember is data that is qualitative in nature. It describes a class or a group that something belongs to. So the way we display categorical data is a little bit different. We use different types of graphs, and that's really, really important that you make the distinction between the types of graphs we use for categorical versus numerical. So make sure at this time you have your notes in front of you, your phone is put away so you're not distracted, and you're ready to focus for the next few minutes. So we're going to start off by talking about a bar graph. One way we display categorical data is using a bar graph. It's similar to a histogram, except it's obviously for categorical data. So whereas histograms are always used with numerical data, categorical data is when we would use a bar graph. The bars do not touch as they do with a histogram. So remember with a histogram, the bins are right next to each other, literally. And finally, with a bar graph, the order of the bars does not matter. And this is a really, really important point. I think this may be the most important little point in this box. And the reason I say that is because with bar graphs, remember you're displaying categorical data. And so with categorical data, everything is classified into different categories of some sort. And the order of the bars makes no difference. With histograms, remember, your bars go from smallest to largest. You're talking about numbers, and so it's on a number line. But with categorical data, the order does not matter, and the bars in the bar graph do not matter. There's no inherent order to any of it. Now, there is one exception to that, and that is called a Pareto chart. So a Pareto chart is a special type of bar chart in which the bars are arranged from largest to smallest, so in descending order, in other words. And sometimes that just, researchers will write it that way so that you can see which one is the tallest bar pretty easily. A couple of other little distinctions between bar charts and histograms. So with histograms, remember the data type has to be numerical data, whereas bar charts, it has to be categorical data. With histograms, the bars touch, and with bar charts, the bars do not. With histograms, the bar width should be consistent, and they can be adjusted to whatever you need that bin width to be. With bar charts, the bar width does not need to be consistent, although I will say, let me write that down, does not have to be consistent, although I will say it would be very strange to have a system where the bars are not consistent. So generally we do make them consistent, although the width itself is not what's important, as it is with histograms. You have that bin width where it really matters. And then with histograms, the horizontal label it's in numerical order, right? It goes from smallest to largest because it's on a number line. Whereas with the bar charts, any order is fine. There is no inherent order. Okay, so I've got a nice little graphic here I just found comparing a bar chart and a histogram. Let me show it to you really quickly here. So this has two graphs. You can see the one on the left is a bar chart, and notice that the bars do not touch. Now, I don't know what these categories necessarily represent, but you can see that with the bar chart, I'm trying to zoom in a little bit, get rid of some of the junk here. There we go. So with the bar chart, you've got categories, A, B, C, D, whatever that represents. Notice that they do not touch. There's gaps in between each bar. And the vertical axis represents the frequencies within each category or classification. And remember, the order does not matter. So I wrote them as A, B, C, D. I could switch these up. It would make no difference. With a histogram, on the other hand, remember you're talking about numerical data. So your x-axis is a number line from whatever you start at up to wherever the data set ends. And then your y-axis still shows your frequencies. So you can kind of contrast and see the difference between a bar chart and a histogram. And we will use StatCrunch to make our bar charts just like we do bar graph, bar chart, same thing. We'll use StatCrunch to do that just like we did for histograms and dot plots. There's one other type of graph we're going to use in this class to represent categorical data, and that would be a pie chart. So a pie chart is literally a circle divided into pieces. And it's, if you've ever seen like a Trivial Pursuit game, you have a little pie chart where you fill in those pieces. Now in that game, the pieces are all the same size, but in reality, when you're doing a pie chart to display data, the area of each portion is relative to the proportion or percentage of data within that piece. So those little wedges for each piece will vary depending on how much of the graph they take up. Let me show you an example here. And here is a quick example. You can see this represents the number of participants per game, whatever this is measuring, I'm not sure, but we're looking at different games. Notice with a pie chart that each wedge is a different color. One thing about pie charts that's nice is that it shows you those different sizes, and so those sizes for each wedge need to be proportional to whatever percentage they're taking up. Notice that Uno is only 4%, whereas, so it's got a very tiny wedge, whereas Candyland is 23% and it's got a much bigger wedge. It theoretically should be taking up 23% of the circle. That's the idea. These are color-coded, and so if you're working in black and white, it's a little bit harder sometimes to see the distinctions in colors, and so that's one negative to using a pie chart versus a bar chart. When you're displaying categorical data, it's generally your choice whether you need to use a pie chart or a bar chart. It's really up to you. I'm going to go ahead and keep talking about I'm going to go on to section 2.4 because we're still talking about categorical data, and this is a really short little section here. But a couple of little tidbits here about how we would describe a categorical distribution. So if you remember when we talked about numerical data, we said we describe it in terms of the shape, the center, and the spread. Well, with categorical data, we're going to use different measurements to describe them. So it says since categorical data has no inherent order. So in other words, remember the order that those bars are arranged, the order of those wedges in the pie, it doesn't matter. These measures of shape, center, and spread that we use with numerical data do not make sense. They don't appropriately describe categorical data. Sometimes I see students will have a bar chart and they'll say it's a skewed bar chart, and that doesn't make any sense. A bar chart can't be skewed because the order of the bars makes no difference. So instead, to describe categorical data, we're going to use two descriptions. The mode, and you can think of that as the most frequent, the typical value, or I shouldn't say value, but the typical category where most of your observations occurred, and the variability. So how much diversity is there among your observations. The mode you can think of as, like I said, the category that occurs most for the data set. Most people said they were going to vote for this candidate, or most people said they use this particular app on their phone, or whatever. That would be your mode. Whichever one is the highest bar in the graph is going to be the most frequent response in your survey. Modes for numerical and categorical data. So with numerical data, we said previously that the peaks in the graph do not need to be the same height, but with categorical data, the modes must be the same or at least close. We can have, in height I mean, we can have data that is bimodal when it's categorical, so that means we have two bars that are roughly the same height. But they've got to be close, very close together, whereas with numerical data, they didn't have to necessarily be the same height. And then finally, variability, you can think of as diversity in the data values. Are there a lot of responses in a lot of categories, or did most people just stick to one or two, maybe three responses? So high variability, sorry, I know I didn't leave enough room here. High variability means you have lots of diversity in your categories, whereas low variability means that you have less diversity in your categories. And it says, remark, variability here is more about really like the term diversity. So really like the diversity in outcomes rather than the frequencies within each category. So if you have a graph where you've got a lot of responses in a lot of different outcomes, whereas a graph maybe you had 10 different categories that people responded to versus one where maybe they only responded to 3 categories. That would be what we mean when we talk about variability. And most of the time on these kinds of questions, we're going to look at 2 graphs and make a comparison. So we'll do some examples of this in class tomorrow. This isn't too bad, but I'll give you some examples tomorrow. We'll look at these together and talk about how to make these graphs, by the way, in StatCrunch, because as I said, you won't be doing any of them by hand. So make sure you bring your notes with you to class tomorrow, and I'll see you then.